Good morning, dear students. So far, we have discussed about waterborne diseases, role of environmental engineer. Of course, before that, we already discussed about necessity and importance of protected water supply as part of environmental engineering 1 curriculum. And we have seen objectives of protected water supply. We have seen all these things, bacterial diseases, viral diseases, role of environmental engineer and all. And I have insisted you in the previous class, and I told you, you must thorough enough about this particular flow chart, because you might have get a question, write in flow chart of water supply system for your coming examinations. In this curriculum, the curriculum has designed from the starting, that means source to consumer. We are going to discuss at different capacities and at different levels of all these things, in the sense about surface water and groundwater. And I told you that this E1 is exclusively designed for water from source to end. And in E2, the rest of the things of environment, like solid waste and all other content, will be discussed in the days to come. As part of curriculum, we have seen and we just entered slowly. We are entering slowly into the topics. The first one is water demand. And here, why water is in demand? Maybe at our localities, you may not be observed about the demand of water. But I am sure, and you may be here, at least if you are not facing that, I know, and you are here, the water is in demand at certain areas and at certain places. That is why the cost of water is keep on increasing season to season and even year by year. So without water, no one can survive. As I told you, and we discussed, as it is the second important parameter of the air for the survival of any human being. See, on average, every human being needs 135 liters per day per capita for all the activities that one has to perform. About this, we already discussed in the previous session, and we have seen all these 5 types of water demand: domestic water demand, commercial water demand, fire demand, public demand, compensated losses demand. We are discussed in detail what is ABCD of this water demand. We discussed. Coming to the topic, see here, what are the factors that are affecting this water, which drives this water in the scarcity component. That means, in the other name, we can discuss all the influencing parameters why water is in demand one by one, in the name of factors influencing water demand. From here, we'll discuss in detail today's session. See here, the first thing is size of the city. Size of the city also one of the factors that can influence this water demand. See here, the consumption of water is always associated with the size of the city, as the consumption will be more with respect to the number of people in the society or city, and the demand will be minimum if the number is reduced. See here, when the population is increasing, the authorities has the prime responsibility to supply water. At one side, the availability of water is reducing year by year. The other side, the population is increasing, and more particularly in the cities, because people used to migrate to the cities for various reasons. The supply of water to the public is under the shoulders of government, of course, authorities, concerned authorities. So what I'm speaking is here the availability of water content, the availability of overhead tanks. Sometimes fail to supply the water because sometimes in the sense if the precautions that the authorities has to take in must be improved and must be monitored every time in such a way that can meet the need of the people, that can meet the need of the increasing population. That means when the population is increasing, the demand is more, and the burden on water is increased, so that the demand will be increased. That's what I want to convey here in the name of size of the city. We are discussing about factors influencing water demand. The next one is cost of the water. Here, cost is one of the parameter to which the water will be in the demand. See here, cost is one of the parameter. The consumption is more when as long as is the price is available. See here, as long as the price is available, the consumption is more, and the same is reduced when the cost has been increased. The cost is minimum, that means the availability will be more. See, that is the reason here always you must remember cost of the water also one of the parameter that can influence the demand with respect to water. When the cost is high, people won't go to high cost, which is not supposed to be. Here, as the cost is affordable, as the cost is reasonable, the demand will be more. If the water bottle cost is 18 rupees, most of the people can go for it. In the same case, if the cost of the bottle is 80 rupees, no one goes. That means the cost of the water also one of the parameter, 18 rupees and 80 rupees. Hope you hear. At 80 rupees, the consumption is more. Sorry, at 18 rupees, the consumption is more, whereas the same is increased 80 rupees, the consumption will be less. See, quality of water. See, the water has to be water has to be supplied to the public in such a way that can be potable and that can be useful for all the activities, and more particularly for drinking. When the quality of water is more, the demand will be good. If the quality of water is less, obviously the demand will be less. What we are discussing here, the topic name is factors influencing water demand. See, next one is pressure head in the pipelines. Pressure head in the pipelines. That means for getting water, for collecting water, the pressure must be suitable. The required pressure has to be maintained in the pipelines. Then only the collection of water will be within the stipulated time. If the pressure is not sufficient, see, the pipelines will be in the open mode, and most of the cases people used to left from the taps as the water is collecting slowly. Because of the patience issues, people will move away, and by keeping the taps in open mode, in such cases the loss will be observed. Did you understand what I said here? Pressure head in the pipelines. Suitable pressure head has to be maintained in the pipelines. When the pressure head is maintained, required pressure head is maintaining, the collecting of water will be good. If the pressure head is not up to mark, the collection of water will goes to sometimes unwanted conditions. That's what I mentioned here. Sufficient pressure has to be maintained to collect the water in a convenient way where the demand is good and even more. If the pressure head is not suitable and not required level, the supply of water, unless the collection of water, the time that has taken to collect the water will be increased. In such cases, there will be or else the demand will be less. That is also one of the criteria to be considered under the factors influencing water demand. Next one is climatic conditions. I said that the demand is good, and the demand is good more towards from midsummer periods, and it reduces gradually towards the winter season. That means here clearly you can understand here. During summer period, the consumption is more, and the same in the same area for the same human beings, the consumption will be less when we move to the winter region. That's what I mentioned here. Even at certain old countries, the cold countries, the consumption is, see here, minus the consumption. See here, you must understand that here cold countries, the consumption is high. Why? The consumption will be more. Why? Because at certain cold countries where the temperature is observing during at minus degrees, people used to keep the taps in open mode. Why? Because if they kept the pipes in off mode, the water in the pipelines will be solidified. Understand? That means the water may not travel from the pipelines. The water will get freeze. If the water is, if the water is not, see, if the water is, not in an open mode, the water in the pipelines will get freeze, and we won't get the water whenever we want the water. That is the reason at certain cold countries, people used to keep the taps in open mode so that the losses of water will be absorbed. If they used to keep the taps in off mode, the water in the pipelines will get freeze. In such conditions, it is not suitable for consumption. That's what I'm specifically mentioning is here. At cold countries, the demand will be more because always the taps has to be in open mode. And next one is industries. Here, industries in the sense wherever the industries are absorbed, wherever the industries are located, at that particular area, the demand will be more because the quantity of water for industries is always depends on the activities that are taking place in the industries. That means, in one word, apart from the people, the water has to be supplied to the industries at consequences at certain point of times the consumption will be more so that the water will be in good demand at industrial areas. Next one is living standards. Here, living standards also one of the parameters that has to be discussed under the factors influencing water demand. Living standards are good if the living standards are luxurious. The water is more. The consumption of water is more because the water will be used for like coolers, swimming pools, maintenance of lawns, and etc. It is directly linking to the luxurious conditions of the people. The living standards are more. The water consumption will be more, where the water will be used for various activities such as swimming pools. That means maintenance of law, swimming pools, maintenance of laws, and coolers. And the consumption is very minimum towards the see here at lowest living standards area. In the same condition, if the living standards are minimum, if the living standards are not up to mark, the consumption will be minimum. That's what I'm saying here. I see here apart from see all the apart from means see we need to discuss. See here, we need to discuss apart from these factors affecting water demand, the factors influencing water demand. Are as fluctuations. Of course, factors influencing water demand, we have seen all these things: size of the city, cost of the water, quantity or quality of water, pressure head in the pipelines, climatic conditions, industries, living standards. Apart from these things, there is one more part with respect to water demand that is titled as fluctuations or variations in the water demand. See here, hourly variations and fluctuations. We discussed in the previous class, there will be a fluctuations in the water supply with respect to days and with respect to hours. See here, during peak hours from 6 a.m. to 10 a.m., the variations or the fluctuations of water demand will be more. because this is a peak time where the people used to use the water for all their daily activities. At the same way, from 4 p.m. to 8 p.m. also, the hourly fluctuations is observed at high rate, and even the water consumption is less during the timings like 12 a.m. to 4 a.m. This is what about hourly fluctuations. And next one is seasonal fluctuations. I said that the consumption of water by the people at any area will be influenced with respect to the climatic conditions. During summer period, the consumption is more. During winter season, the consumption will be less. At certain cold countries, see here, to avoid the freezing of water in the pipelines, the consumption will be will be at a peak points, at peak levels. Seasonal fluctuations. This is what about seasonal fluctuations. During summer areas, summer period, the consumption is more. At the same time, during at certain cold countries, the consumption is more. Why? Because to get the water from the pipelines will be always in open mode to avoid the freezing of water in the pipelines. In that particular point also, the consumption is more and the variations will be more with respect to the seasons. That's why the variations will be more with respect to the season. This is what about water demand. See here, we have seen this water demand. What are the types of water demand? The first one we have seen, what is water demand? And now how much of water that man has to be has to be taken for his survival. See here, types of water demand. We have seen domestic water demand, commercial, industrial, or institutional demand. Five demand, public demand, compensative losses demand. That common domestic water demand again has been divided into all these different activities: drinking, cooking, bathing, washing, cleaning floors, cleaning dishes, flushing purpose, etc. See, after domestic, we have discussed industrial water demand, and after that, followed by fire demand, followed by, see here, the fire demand will be calculated with the many empirical formulas. We just mentioned two, and we discussed Kuchling's formula and Boston's formula. And next one is compensative losses demand. The losses which may occur during the supply of water will comes under compensative losses demand we discussed. See here, and next we have seen factors influencing water demand. In that we have discussed subtopics like factors like size of the city, cost of the water, quality of water, pressure head in the pipelines, climatic conditions, industries, living standards. And also we have discussed fluctuations or variations in the water demand by name, hourly variations or fluctuations, and seasonal fluctuations. Now is the next topic is per capita demand. What is this per capita demand? Per capita demand in the sense, at any area when the water is being supplied to the pumping system, there is a need to estimate the per capita demand in order to meet the basic needs. At any area or any locations, we need to know how much of water is required to meet the basic needs of the people of that particular area. And how can we calculate the per capita demand of one particular area? Simply by adopting the formula Q by P into 365, where P is population, Q is quantity of water. The per capita demand of any area is completely depend on the local existing conditions, and it can be explained with the following table. Again, what is per capita demand? See here, per capita demand has to know to the water suppliers to supply the required quantity of water. See, how can we calculate per capita demand is nothing but by adopting the formula Q by P into 365, we can calculate the per capita demand. See here, the per capita demand exclusively depends on the existing climatic conditions or existing conditions of that particular area. See here, this is about the per capita demand at different capacities, different areas. When the population is up to 20,000, the per capita demand is 110 liters per day per capita. You must remember this table, and you must remember all these figures. See here, we have seen at water demand, the average consumption of water per day is 135 liters per day per capita. See here, per capita demand in with respect to the population, up to 20,000 population, 110 liters per day per capita, 20,000 to 50,000, the per capita demand 110 to 150 liters per day per capita, 50,000 to 2 lakhs population, 150 to 180 liters per day per capita. When the population is 2 lakhs to 5 lakhs, the per capita demand will be 180 to 210 liters per day per capita. When the population is 5 lakhs to 10 lakhs, the per capita demand will be 210 to 240 liters per day per capita. If the population is above 10 lakhs, the consumption will be 240 liters per day per capita and even more. This is what about per capita demand. And next one is design period. You must remember what is per capita demand, and see per capita demand will be find out by using this formula. By using this formula, see here per capita demand various areas is like it's here. I just mentioned here. See per, and it can be explained with the following table. Yeah, the per capita demand is always with respect to the population. When the population is like this, the water demand will be like this. I mean like this in the this as per the third column. When the population is as per the second column, the population per capita demand as per the third column with respect to various locations. Here next one is design period. The next topic is design period. Here we are design period. What is the period? See how, see here you have in your ID card. See when ID card is preparing, and that has to be meet the requirements of all your 4 years. That means design period in water supply engineering. What is this design period? Design period in the sense it can be defined as, there itself we can understand. The slide is clearly resembling, clearly speaking to us. It can be defined as the number of years in future of which the given facility is available to meet the requirements, or it can also be defined as the number of years in future of which the water supply is more than the demand. Seeing here, I can explain this here. It number of years in the future up to what, or else up to what extent it is going to meet the requirements of the purpose. Again, it can be defined as number of years in future which the given facility is available to meet the requirements. See, that means if you purchase one particular point, say mean if you purchase your mobile phone and you know how long you can use this, how can, or else the manufacturer knows how long it can be useful, how long it can be used. That means he has a basic idea how long it can be used based on the, I mean the nature of the particular what I can say, the particular thing. That means when the mobile phone is being manufacturing, he knows that how long it will be useful, it can be workable. That means for everything there is an expiry period. See, for as a human beings, here we have an expiry date. We have an expiry date. Up to what extent we can survive, that you know. See, and with respect to water supply system, if you are going for any structure, you must remember up to what extent it should be useful to meet the requirements of the particular people. That's what I mentioned here. See here, it can be defined as the number of years in the future of which the given facility is available. How long this particular structure is going to be available to meet the requirement comes under the that particular number of years comes defined as the design period. See, and see here, factors affecting design period. What are the factors that can influence the design period? See here, water supply. See, in water supply system, so the design period is must and should. The design period, the knowing of design period is highly mandatory to go for various, while we are going for various structures. In that factors, the first and foremost thing is life expectancy. Life expectancy, how long, for suppose we are going for one water overhead tank, and we have a pre-assumption that how long this particular tank has to be useful to the colony people. Based on the period, you can choose the materials to meet the number of years in the future what you are assuming to meet the requirement. See here, That's what I mentioned here. The life expectancy of any structure must be as per the requirements of design period. There are different materials to be used in water supply system which can be adapted as per the requirements. Normally, the life expectancy must be more than the design period. See here, the design period of one particular structure is, if the design period of one particular structure is 20 years, if you go for the materials that are using to supply the water, which has the life expectancy of 15 years, the remaining 5 years, how can you supply? That is the reason the the materials or else the things that you are selected to go for one particular structures whose design period is already fixed, the design period, the life expectancy of materials must be more than the design period. Then only we can successfully meet the requirements of the particular thing or as particular purpose. Understand here? See here, did you understand that this point? The life, normally the life expectancy must be more than the design period. For suppose the design period is 20 years, if the I mean the pipelines that are used, for suppose one water tank is there, one overhead tank you are designing, which should be there in your thoughts for 25 years. The pipelines that you are selected whose life expectancy is only 15 years, you can't supply the water up to 25 years because the life expectancy of pipe materials that you are selected is only 15 years. That means after 15 years you must go for other pipelines because the design period of the life structure is 25 years. If you are selecting the materials whose life expectancy is more than the design period, easily we can meet the purpose of the particular thing or as particular, or I mean particular project. Understand? See here, the steel pipes life expectancy of different materials. Steel pipes 25 to 30 years. Concrete pipes 75 years. Cast iron pipes 100 years. See, if the life expectancy of one water supply system is 20 years, the design period of one particular overhead tank is 20 years. For us, suppose if we go for steel pipes, we can successfully supply the water as per the design period. If the design period is 40 years, if we go for steel pipes, as the life expectancy is only 25 to 30 years, the rest of the 10 years we should go for other pipelines. In such cases, if we go for concrete pipes, we can easily meet the requirements of design period. That's what I meant. I want to speak here. Convey here. See here, normally the life expectancy must be more than the design period. See here, we have started design. What is design period? And we are apart from the definition, we started factors affecting design period. In that we have discussed the first point, life expectancy, and the remaining what are all the other factors that we must consider regarding when the design period is when the design period is being calculated, the design period is estimating. Or else when the once the I mean we'll go for other parameters that can influence the design period, or else that can affect the design period. We have discussed the first point, that is life expectancy. In the next class we will discuss other affecting factors of design period. Up to here, today we discussed about the factors affecting water demand. We discussed the fluctuations of water demand. We have discussed per capita demand, and we started design period. In that, factors influencing design period, we are discussing different points. We already discussed about life expectancy. The other parameters will be discussed in the next class. Thank you. If you have any doubts, please contact me, whatever the domain you feel convenient, by phone, message, or mail. Thank you.